This video is about more on calculations and is a triple only video. So in a previous video we looked at how to calculate concentration, but you also have to be able to calculate concentration in moles per decimeters cubed. So I'm going to show you how to do that now. So the calculation we need to be able to remember is that concentration in moles per decimeters cubed is equal to the amount of solute, and this is in moles, divided by the volume, and this is of course in decimeters cubed. So let's go through a worked example. What is the concentration of a solution with 4 moles of sugar in 300 decimeters cubed? So we're working out our concentration, so it's going to be concentration is equal to, and we need the solute in moles. So we've got 4 moles here, and that's going to be divided by the volume in decimeters cubed. Now that's 300 decimeters cubed, so we do concentration is 4 divided by 300. We pop that into a calculator and we get 0.013. Now the units here are moles per decimeter cubed. And that is our answer to that question. Here we have another worked example. So what is the concentration of solution with 8 moles of sugar in 300 centimeters cubed? So you'll of course remember that the equation that we must be using is concentration, which is in moles per decimeters cubed, is equal to the amount of solute in moles divided by the volume in decimeters cubed. So here again we're trying to work out the concentration, and we've got the solute, which is 8 moles, divided by the volume, which is 300, but we've got to be careful here because it's 300 centimeters cubed and we want decimeters cubed. So to get from centimeters cubed to decimeters cubed, you have to divide by 1,000. So 300 divided by 1,000 gives you 0.3, and that will now give you it in decimeters cubed. So we can take this number, the 0.3, we can pop it under our calculation here. So concentration equals to 8, which is the solute in moles, divided by the volume, which is in decimeters cubed now, which is 0.3. Pop that into a calculator and you get 26.7, and of course it's moles per decimeter cubed. So we'd now like you to have a go at these to really check your understanding of this lesson so far. So pause the video now. Okay, so let's go through the answers then. So of course the equation for each of these that we need is concentration, and that is of course in moles per decimeter cubed, is equal to the amount of solute in moles divided by the volume, which is in decimeters cubed. Okay, so let's go through the answers then. So for 1, what is the concentration of solution with 2 moles of sugar in 600 decimeters cubed? So here we just do the moles divided by, of course, the volume, which is 600. So 2 divided by 600, pop that in the calculator, you get 0.003. Don't forget the units, moles per decimeters cubed. For question 2, what is the concentration of solution with 5 moles in a 400 centimeters cubed? So concentration is equal to solute in moles 5 divided by the volume, but it's in decimeters cubed. Here we've got centimeters cubed, so we have to convert it. So centimeters cubed to decimeters cubed divided by 1,000. So 400 divided by 1,000 is 0.4. So that's 5 divided by 0.4, and you get 12.5 moles per dm cubed. For question 3, you should have done 3 divided by 0.3, because again it's in centimeters, we needed to convert it. You pop that into a calculator and you get 10 moles per decimeter cubed. For question 4, you should have done 9 divided by 700. This is in dm cubed, therefore we don't have to convert. Put that into calculator, get 0.013 moles per decimeter cubed. And then finally, 14, for the last one you should have done 14 divided by 0.9, as we've converted this to decimeters cubed. And you should have got 15.56 moles per decimeter cubed. Now you can also work out the concentration of one solution from the concentration of another. Okay, now you really do have to make sure you're familiar with concentrations, the equation which was on the previous slides and the previous video as well. So I'm going to take you through a work example to show you how to do this in practice. Okay, I'm going to try and go through it slowly. I'm going to go through 2 worked examples and I'm going to give you the chance to go through your own, as this can be quite a difficult topic to understand. So here we have 25 centimeters cubed of an unknown concentration of sulfuric acid is titrated against 13 centimeters cubed of a 1.8 mole decimeter cubed solution of sodium hydroxide. What is the concentration of the unknown solution? Okay, so the first thing we have to do to answer this question is we have to construct a balanced equation. Okay, so let's put this together. Okay, so we know, of course, that we've got sulfuric acid and we're mixing it with sodium hydroxide. Okay, so sodium hydroxide, NaOH, okay, plus our sulfuric acid, which is H2SO4. And if you're unfamiliar with these, then go and watch the videos on acids and alkalis and you'll understand these a bit more. And then this obviously makes sodium sulfate. And again, if you didn't know that, then it's a good idea to go and watch the videos on acids and alkalis and reactions of acids to really understand this. And it makes water as well. Now the second thing you have to do is you have to balance that equation. Okay, so again, you should know how to balance the equation if you've watched the video. If you don't, I would suggest going back to watching that. But to balance this equation, which is proper 2 there and a 2 there. And again, if you do need help balancing an equation, then please go back and watch the previous video. The first step is writing out that balanced equation. The second thing we're going to do is we're going to get all the data that we know of the known substance. So what I'm going to do is I'm going to write known here and under my balanced equation. And the known one, so unknown is here, and that's sulfuric acid, so that's the one we're trying to work out. The known one, therefore, is sodium hydroxide. So I'm just going to write that known is our sodium hydroxide. Okay, just so I remember that. And then I'm going to write all of the information I've got. So, concentration of our known substance, if we look, is 1.8 moles per decimeters cubed. Okay, so I'm going to write that there. And then our volume of our known substance is 13 centimeters cubed. Okay, but we know when we're dealing with our moles that we need that in decimeters cubed, so it's always a good thing to convert it now. So 13 divided by 1,000, because remember we divide by 1,000 to get to decimeters cubed, is 0.013. And now what we need to do is we need to calculate the moles, okay, the number of moles from this. And if we rearrange the equation that we just looked at, we can get moles is equal to concentration times volume. Okay, so if we go back to our previous and this equation here, we've just rearranged that equation there to get moles is equal to concentration times volume. So that means we can work out the moles because we have the concentration and the volume. So all we have to do is we have to times them. So to work out moles, we do concentration, which is 1.8, times volume, which is 0.013. And that is going to get us 0.0234 moles. Now what we need to do then is we need to split our page and we need to write our unknown. Now the unknown is sulfuric acid, which is our H2SO4. So that's what we're trying to work out the concentration for. It's an unknown concentration. So we're going to write concentration, and next to that we're going to write a question mark because that's unknown. Then the volume, okay, if we go to our question, is 25 centimetres cubed. Okay, so that's given us there. So 25, again, we're going to need it in decimeters cubed. So we may as well convert it now. Divided by 1,000. Okay, and therefore it gives us 0.025 decimeters cubed. And then we need to find our moles. Now we can do this by looking at our equation. So if we go back to our equation, we know that for every 2 moles of sodium hydroxide, we need 1 mole of sulfuric acid. That means we need half the amount of sulfuric acid than we do sodium hydroxide. Okay, because there's 2 moles here, 1 mole here, that's half. So we've got 0.0234 moles of sodium hydroxide. We've just said there that we need half of the number of moles of sulfuric acid. So what we're going to do then is we're going to divide that by 2 to get half. So 0.0234 divided by 2 gives us 0.0117 moles. And now we can use this equation and we can rearrange it to get the concentration. Again, that was the same equation as our previous video here. Concentration equals solute moles divided by the volume. Okay, so let's write that up here. Concentration is equal to our number of moles divided by our volume. And if we put that into our equation, okay, so here we've got our moles, which is 0.0117, divided by our volume, which is 0.025. That will give us our concentration. Put that in the calculator and you get 0.468. Now we've just worked out concentration, so it's moles per decimeter cubed. And that is your answer to this question here. Now, if you think you really understood that, it could be a good idea for you to pause the video to have a go at this one. If not, I'm going to go through another example now. So we've got 22 centimeters cubed of an unknown concentration of potassium hydroxide, and it's titrated against 17.5 centimeters cubed of a 1.15 mole decimeters cubed of sulfuric acid. So the first thing we need to do, remember, is write that balanced equation. So we've got potassium hydroxide, which is KOH, plus our sulfuric acid, which is H2SO4, and we know that's going to make a potassium sulfate, plus water. And again, we need to balance this equation. So to balance it, this is the balanced equation here. So the first step, the next step, we need to write the figures down for the known value, or what we know. So again, I'm going to write known. So it's unknown potassium hydroxide, that's unknown, and therefore this time it's known the sulfuric acid. That's what we know. So we're going to write that here, H2SO4. Now the concentration of our sulfuric acid, if we look, is 1.15 moles per dm cubed. Okay, and our volume, if we look, is 17.5. So again, we're getting that from the equation here. We're going to divide that by 1,000 to get it into decimeters cubed, which gives us 0.0175 decimeters cubed. And then we can work out our moles. Remember, using moles is equal to concentration times volume. We've just rearranged that equation. So concentration 1.15 times by our volume 0.0175, and we get 0.020125 moles. Now we're going to go over to our unknown, and that's what we're trying to work out. So its unknown is potassium hydroxide, so it's KOH. So the concentration of this unknown is what we are trying to work out. The volume is 22 centimeters cubed, but we need to convert it, so divide it by 1,000. We get the volume, of course, as 0.022. And then the moles, remember, this is where we go look at our equation, our balanced equation. So for every 2 moles of potassium hydroxide, we need 1 mole of sulfuric acid. Okay, so we need double the amount of potassium hydroxide as we do sulfuric acid. So if we've got this amount of moles of our sulfuric acid, we need double that for potassium hydroxide, so we're going to times it by 2. So 0.020125 times 2 gives you 0.04025. Now once we've got that, we can use the equation from before. That concentration is equal to the moles divided by the volume. So concentration equals the moles, which is 0.04025, which we've just worked out, divided by the volume, which is 0.022, which we've got from here. We pop that into our calculator and we get 1.83, and the units are moles per decimeter cubed. So this can be quite a difficult concept to understand, so it's a really good idea to test yourself now. If you think you can construct your own balanced equation, then pause the video now and have a go. If not, I'm going to balance the equation for you, write it out for you, and then I'll tell you to pause the video to have a go at the rest of the equation. So here we've got our 20 centimeters cubed of sodium hydroxide, and it's titrated against 26.3 centimeters cubed of a 2.5 mole solution of sulfuric acid, and we've got to work out the concentration of the unknown. So let's construct our balanced equation. So it's sodium hydroxide plus our sulfuric acid, and as we said, it makes sodium, sulfate and water. And to balance that equation, we do that. So if you watch me balance that equation and you needed me to do that, then pause the video now to have a go at the rest of the equation. Okay, so let's go through the answer then. So first of all, as ever, after that, we're going to write down our known. Okay, now the known one is this one here, so it's sulfuric acid. So we're going to write sulfuric acid there. Our concentration is 2.5 moles per dm cubed. And then our volume is 26.3. But we need to convert that, don't we, to decimeters cubed, so we're going to divide it by 1,000 to get 0.0263 decimeters cubed. We can then work out the moles, okay, using the equation moles equals concentration times volume. So you would have done 2.5 times 0.0263, and for your answer you would have got 0.06575 moles. And then we're going to go over to our unknown, and this is what we're trying to work out. It's unknown of sodium hydroxide, so let's write that here. And the concentration is unknown, so we're going to write a question mark next to that. Our volume, okay, in our equation is 20 centimeters cubed. We're going to convert that, of course, so we get 0.020 decimeters cubed. And on our moles, this is where we go to the balanced equation. So if we look here, we need double the amount of sodium hydroxide than we do sulfuric acid, because there's 1 mole here and 2 moles there, so we need double the amount. So if we've got this here, we need double, so we're going to times it by 2, so we're going to have 0.1315 moles. So we've just done 0.06575 times 2 to get that there. We can then use the equation concentration is moles over volume to get our concentration. So moles 0.1315 divided by our volume, which is 0.020. Okay, you pop that into a calculator and you're going to get 6.575 moles per decimeters cubed, and that should have been your answer for this question here. And here is another question to have a go at. Again, if you need me to construct the balanced equation for you, then stick around. If not, pause the video now to have a go. Okay, so let's first construct this balanced equation. So we've got sodium hydroxide. Again, we don't know the concentration. And we're mixing, if we look at that, with hydrochloric acid. Okay, so we're mixing that with hydrochloric acid. So our equation is going to be sodium hydroxide plus hydrochloric acid. and that is going to form sodium chloride plus water. Now that is actually already balanced like that, so you don't need to balance it now. So if you did need me to balance the equation for you, pause the video now to have a go at the rest of the question. Okay, let's go through the answer then, and as ever we're going to start with our known. Okay, and our known in this one is our hydrochloric acid. Okay, this hydrochloric acid here, this is known. Now the concentration of the hydrochloric acid is going to be 2 moles. So that's our concentration. And then our volume, if we look, is of course 21 centimeters cubed of hydrochloric acid. Okay, so 21. And then we need to convert that. Okay, so we're going to do 0.021. We've just divided by 1,000, remember. And then we can work out our moles using the equation moles equals concentration times volume. So concentration is 2 times volume, which is 0.021. We get 0.042 moles. And then we're going to get our unknown. Okay, now our unknown in this example is our sodium hydroxide, so we're going to write that here. Sodium hydroxide, but we don't know the concentration, so that's the unknown. We're going to write concentration underneath is a question mark, and then the volume that we've got. So we take exactly 25 centimeters cubed of sodium hydroxide. Okay, we're going to convert that by dividing it by 1,000 into decimeters cubed. And then the moles is where we need to look at our equation. Now if you see here, you need 1 mole of sodium hydroxide per 1 mole of hydrochloric acid, so they're equal. So if we have 0.042 moles of hydrochloric acid, we're going to need 0.042 moles of our sodium hydroxide. Now we've done that, we can use the equation concentration equals moles divided by volume. So the moles is 0.042 divided by the volume, which is 0.025. You pop that into a calculator and you get 1.68 moles per decimeter cubed. And that should have been your answer. Now today that's quite a long and difficult topic, and there are plenty more practice questions for you to have a go at on the website. As ever, and this is really important, even more important on this video, if there's anything you didn't quite understand, please do get into contact with one of our tutors and they will happily help. Why are we the best revision website out there? Well, because we have it all in one place. Revision notes, summary videos, longer, more detailed videos for topics you're struggling on, exam question walkthrough videos where qualified teachers take you through the perfect answers to exam questions, worksheets, quizzes, computer marked exam questions, interactive flashcards, forums, the ability to keep track on where you are using our tick list, and so much more. But that's not all. We run at least 3 live lessons a week, and closer to exam time, this will be more, where you can tune into a qualified teacher teaching lots of different topics each week. The lessons will be interactive, and we go through exam questions and quick quizzes to ensure understanding as you go. We also run drop-in sessions where you can drop in, ask a tutor anything live, get the answer that you need, and leave. These are included in our silver and gold membership. This means that for an extra £10 a month, you can access at least 12 hours of lessons a month. That's under £1 an hour, which is incredibly cheap. Still not convinced? Try us completely free for 7 days and cancel anytime, completely free of charge. We offer this because we're convinced that you'll love us. So try us now.